systems. So suppose you take a line and I rotate it about some point, okay? If I do that, I will create a cone going in two directions. We'll call this point that we're spinning around, this fixed point, the vertex, and the napes, this thing that you're sort of spinning. We can take planes that go through either the napes or maybe a vertex or whatever. If it goes through if I take a plane that intersects through a vertex, we'll call that a degenerate conic. And well, doing that, you can either get a point, one line or two lines, or an empty set, actually. Well, if it doesn't go through, so it's either a point, a line, or two lines. Those would be called the degenerate conics. The non-degenerate conics are planes that do not pass through the vertex. These will be called non-degenerate conics that are of the form of a circle, an ellipse, a parabola, or hyperbola. Let's see if I can show that. So this is kind of a busy sort of picture, but okay, see if you can understand this. So here is my vertex, and here is my conic. I've sort of spun this around, and it creates this ice cream cone that goes off forever, attached to another ice cream cone going off forever, attached at this vertex. Okay, so if I get a plane and slice it this way, I get 1 point. If I slice it along this edge, I'll get 1 line. If I slice it straight on where it just cuts these two edges, I'll get 2 lines. If I slice it straight across, I'll get a circle. If I slice it with a little bit of an angle here, I'll get an ellipse. If I slice it across here, where it only intersects one of these at this angle, then I'll get a parabola. Whereas if I slice it, let's see, going through both of these parts of the cone, then I'll get something called a hyperbola. And so intersecting this cone with these planes gives us these conic sections, both, and of course if you slice it where it doesn't intersect these at all, then that's the empty set. So that is the conic sections, both the degenerate and non-degenerate ones. In this chapter, we'll be looking at the non-degenerate conics. So we can think of it in another way. A conic section are just solutions of the following quadratic in the variables x and y. Ax squared plus bxy plus cy squared plus dx plus ey plus f equals 0. So solution to this can have several differing forms. It could be an empty set. You have no solution. X squared, and when I say no solution, I mean a solution in the reals. So you could have something like x squared plus y squared equaling 1, equaling -1, in which case the solution set would be the empty set. Or you can have the empty, you could have 1 point, say x squared equals, x equals 1. That's 1, that's maybe 1 point. You could have a line, a circle, ellipse or parabola or hyperbola. So where can you see this? Well, if you get a martini glass, it has to be a martini glass because it looks like a cone, and you fill it with some sort of liquid, then as you drink it, if you look down, you go, oh, I have a circle. You tip it. It is a ellipse. You tip it more, a parabola. Tip it more, hyperbola. Tip it more. It's a line. Tip it more. It's a point. Tip it even more. Well, it's nothing. No. And so you go through the conic sections as you look at your drink in a martini glass. So let's look at these non-degenerate conics. So first we're going to be looking at circles and parabolas. And so a circle is the locus of all points equidistant from a fixed point called the center of your circle. And this fixed distance is called the radius of the circle. Segment joining 2 points on the circle, passing through the center of the circle, is called the diameter of the circle. And so a circle is the locus of all points equidistant, called the center of your circle. And this distance here that they're all equidistant from is called the radius. A diameter is a line segment connecting 2 points in the circle, passing through the center of the circle. The standard form for the equation of a circle, well, if you have some point here, x, y, let's say it's in the first quadrant, so it's easy to draw, and the length of this is x, the length of this is y. By Pythagorean's theorem, I have x squared plus y squared equals r squared, if r is the radius of your circle. And so this is the standard form for the equation of a circle centered at the origin of radius r. If you just translate this so that the center is now at the point hk, well, then you just use the transformation. You place x by x minus h, y by y minus k. So the equation of your circle centered at hk of radius r is x minus h quantity squared plus y minus k quantity squared equals r squared. Let's look at a parabola. So a parabola is the locus of all points in the plane that are the same distance from a fixed point f called the focus, and they're the same distance as they are from a fixed point, from a fixed line called the directrix, and I'll denote that by d. So the distance from your focus to some point P is the same as the distance from the point P to the directrix. So a parabola is the locus of all points whose distances from a fixed point called the focus and a fixed line called the directrix are always the same. So these distances at any point on the parabola are always the same. So again, this line here is called the directrix. This point here is called the focus. If I take a line passing through the focus perpendicular to the directrix, this would be called the axis of symmetry. If I take the intersection between the axis of symmetry and the parabola, this would be called the vertex. If I take a line passing through the focus parallel to the directrix. This is called the lotus rectum. So let's try to determine the equation of a parabola. So I sort of stated it back in like chapter 3 or something, or 4, that probably 4, that the equation of a parabola had a certain form, but didn't really say why. So let's try to determine, well, the equation of a parabola. So again, suppose I have some directrix. Let me quadratize this. So suppose that this is a parabola whose focus is at the point 0p. So I'll have a coordinate axis where the focus is at 0p and where the directrix has the equation y equal negative p, meaning that the vertex is at the origin. So I want the vertex to be at the origin, the focus to be along the y-axis, and the directrix to be parallel to the x-axis. I put this in the first quadrant, but again, I'm not really saying if p is just the way I've drawn it. It looks as if p is positive, but doesn't necessarily have to be. So first, let's recall. Well, before I leave this picture, let the point on the parabola have coordinates x and y. Since the y coordinate for this, any point on the directrix is negative p, I have that this point has a y coordinate negative p. In order for it to be a distance from a point to a line, I want it to be the minimum distance. In this case, that means it's going to be parallel to the y-axis, perpendicular directrix, meaning that it'll have the same x coordinate as the point. So the point on the directrix closest to the point P has the coordinates x minus P. And so the distance between these are determined by these 2 points. And we want that these 2 distances are the same. Well, let's recall what is the distance between the formula, the distance formula between 2 points in the plane. So let P have coordinates x1, y1, Q have coordinates x2, y2. Then the distance between P and Q is just the square root of the sum of the squares of the differences between the x and y coordinates. Okay, so let's look at the parabola, and let's look at each of these 2 distances. Okay, so first let's look at the distance from the focus to the point P. So this distance here, well, it'll be the difference in it will be the square root of the sum of the squares of the differences between the x and y coordinates. So I'll take the square root of x minus 0 squared plus y minus p quantity squared. And so that's the distance between F and P. Let's look at the distance between D and P. Well, distance between D and P is the square root of the sum of the square of the distances of the difference between the x and y coordinates. So it's going to be the square root of x minus x squared plus y minus a negative p squared. Subtracting negative p, same as adding p. And so it's just the square root of x minus x squared plus y plus p squared. Square both sides of your equation. Of course, x minus 0 is just x, and x minus x is 0. So 0 squared plus anything is just that anything. So square both sides of my equation. So the square gets rid of the square root. And let's simplify this by the special product formula. Y minus p quantity squared is just y squared minus 2 yp plus p squared. And well, square this, so this is just y squared plus 2py plus p squared. The p squares cancel, the y squares cancel. Add 2py to both sides of my equation. X squared equals 4py. That is the equation of my parabola. Notice it's a quadratic. And so this is the equation of a parabola where the focus is at 0p and the vertex is at the origin and the directrix negative p. If p is greater than 0, then this parabola points upward. If p is less than 0, it points downward. Let's do the same thing, but now let's look for the equation of parabola where the vertex is at the origin, but now the focus is along the x-axis and the directrix is perpendicular to the x-axis. So in the case that the vertex is at the origin, the focus is at P0. The directrix is x equal negative p. Again, I'm not assuming p is greater than 0. Then by analogous, doing the same sort of calculation, I just interchange x and y. So I get that y squared equals 4px. And that's the equation of your parabola. If p is greater than 0, then it opens to the right. If p is less than 0, it opens to the left. Similarly, we can translate. And so, if the vertex is at hk, the focus is at hk plus p, and the directrix is at y equaling x minus p, then the equation of my parabola is x minus h quantity squared equals 4p times y minus k.
Professor,
Again,
for that,
question.
yeah, for the f h k plus p, is that the focal point?
Yes, this f
Okay.
is the focus. Mm-hmm.
So
So f is the focus.
I'm trying to understand, how did you get the k plus p?
Because I add h and k. So I'm just adding h and k here to this. So if I look at this, all I'm doing is I add h and k. So I'm just adding h and k here.
Oh, I see. Okay.
So it's this exact thing. I'm just adding h and k.
Okay.
Okay. It's a transformation.
Okay, I thought we were looking at a different problem.
Yeah. No, it's the same thing.
Okay.
So that's why. And then so p greater than 0 goes up, p less than 0 goes down. Lastly, if you do a translation of this one, so if I translate this guy here and I move it over to hk, then the vertex will be at hk. The focus will be at h plus pk, and the directrix is x equaling h minus p. So the equation is just y minus k squared equals 4p x minus h. If p is greater than 0, it goes to the right, less than 0, to the left. So in summary, if a is greater than 0, then I can say the following. Y equaling 4ax, so y squared equaling 4ax, has a vertex at the origin, a focus at a0, directrix at x equal minus a, and it opens to the right. Y squared equals minus 4ax. Vertex is at the origin. Focus, negative a0. Directrix, x equal a, and it opens to the left. So notice the relationship between a and minus a here. It'll be the same going throughout this. X squared equals 4a y. Vertex is at the origin is at 0a. Directrix y equal minus a, and it opens up. X squared equals minus 4ay. The vertex is at the origin. Focus is at 0 minus a. The directrix a, and it opens downward. Okay. Next, if I do a translation, all I'm going to do is just translate these statements. So I'll just replace x and y here by x minus k and y minus h. You'll have to add h and k to each of these. And so I have y minus k quantity squared equals 4a x minus h. Vertex is at hk. Focus is at h plus ak. The directrix is at h minus a, and it opens upward. Let's look at this guy. Let's translate this guy here. Y minus k squared equals negative 4a x minus h. Vertex is at hk. The focus is at h minus a k. And the directrix is that x equaling h minus h plus a. Let's look at this one. And so let's translate this. So x minus h squared equaling 4y minus k. So this again will be at hk. This vertex, so the vertex will be at hk. The focus will be hk plus a. The directrix will be at y equaling k minus a. And then lastly, let's translate this guy. So x minus h squared equals negative 4a y minus k. So the vertex is at hk. The focus is at h k minus a. The directrix is at y is equal to k plus a, and it opens downward. Okay, so where would you encounter parabolas? Well, if you throw a rock and suppose that the only force on the rock is gravity. So there's no air or anything of that sort. And so you just throw a rock, it would parabolic curve. Next, suppose that you have some comet and it only goes around the sun once. One of the possible paths that it could take is parabolic. Next, suppose you happen to have cable TV, no, not cable TV, some sort of satellite TV. So on top of your house, they install, or in on the backyard of your house, they install some sort of satellite dish. This satellite dish is parabolic in nature. It's actually a paraboloid. It's a parabola, but they spin it along an axis, so it becomes three-dimensional. And then if you look at your actual satellite, actually it's kind of like a plastic sort of nodule sort of at the end of a bar. And this actually is located at the focus. So this is a paraboloid, and they have, well, the collector is at the focus. Similarly, if you had a radio telescope, say this is Arecibo or something, they have a collecting device here at the focus. Let's say this is a horrible picture. Let's say that this is your head and this is your eye here. Well, the eye consists of a lens, and the lens here hopefully focuses at the focal point of your eye. If not, then you have to wear glasses. Similarly, a spotlight is parabolic, it's a paraboloid, and the lighting source is located at the focus. So if you actually look at a spotlight, what you'll see is it looks like some parabola. So let's do some examples. Let's say on page 666, write an equation of each circle shown or described. Write your answer in standard form. And then in general form. We actually, well, the general form for the equation of a circle, I didn't write it down, is, let's see if let me go way back up here. I didn't know they want the general form. Okay, let's stop. Let me just put in the general form for the equation of a circle. Okay, so the general form for the equation of a circle is just x squared plus y squared plus ax plus by equaling c. So that's the general form for the equation of a circle. Okay, let's see where we're at. Okay, stop. Okay, so let's do this. Yeah. So I want to figure out, well, the center of a circle. So I have a diameter. The diameter is such that the center is such that it is the midpoint of a diameter. So let's recall what a midpoint is. Let's determine the center of your circle. Okay, so to find the center of my circle, I want to find the midpoint, which is just the sum of the x coordinates divided by 2, the sum of the y coordinates divided by 2. So my center will be, well, 5 plus a negative 2 over 2, 4 minus 3 over 2. And so my center is located at the point 3/2, 1/2. Okay. Now, let's try to determine the equation of my circle. Well, let's recall the standard form is just x minus h squared plus y minus k squared equaling r squared. Okay, so I know what the center of my circle is. So I have x minus 3/2 squared plus y minus 1/2 squared equals r squared. So now let's try to determine what r is. So let's just plug in one of the points on my circle. And so I can plug in either of these 2 points. Maybe I'll plug in 5, 4 because they're positive numbers. So let's plug in 5, 4. And so 5 minus 3/2 squared plus 4 minus 1/2 squared equals r squared. And so that's 10 halves minus 3/2 is 7 halves. 4 is the same as 8 halves minus 1/2 is 7 halves. 7 squared is 49. 2 squared is 4. So I get that r squared is equal to 49 over 2. So I can determine the equation of my circle in standard form. And so in standard form, it's just x minus 3/2 squared plus y minus 7 minus 1/2 squared equals 49 over 2. And that's the equation in standard form. The equation of my circle in standard form. Now let's try to determine the equation in general form. Oh, come on. So the equation in general form. So the equation in general form is, well, let's square this out. So it's just going to be x squared minus 3/2 times x times 2 is a minus 3x plus 3/2 squared is 9/4 plus, let's square this. And so I get y squared. Y times negative 1/2 times 2 is minus y. 1/2 squared is 1/4, equaling 49 over 2. Let's multiply everything here by 2. So I get 2x squared minus 6x plus 9/4 plus 1/4 is 10/4, which is 5/2, times 2 is 5 plus 2y squared minus 2y equals 49. Subtract 5 from both sides of your equation. So 2x squared minus 6x plus 2y squared minus 2y is equal to 44. Divide everything by 2, so we get x squared plus, let's write the y squared first, minus 3x minus y equals 22. And that is the equation of your, well, let's write it as minus 22. That's the equation of your circle in general form. Okay. Let me do problem number 30.
Hey, Professor Q, can you give me a second to copy the previous, please? Thank you.
Say again.
Oh, can you let me just copy?
Oh, okay, sure.
Thank you. Okay, thank you. I'm done.
Okay then. So, find the vertex, focus, and directrix of each parabola. Oh, okay, so this, we're just going to sort of read these off. So first off, it's in the form of y minus k squared equaling 4p x minus h. Okay. So in this case, p is going to be 7, and h is 2, k is negative 1. So let's find the vertex. So the vertex is just hk, 2, negative 1. The focus oh, maybe I should. So the vertex, maybe I'll say that, is at hk. The focus is at, and let's see, this is a square. What's squared? The y is squared. Okay, so that's fixed. So this is going to be h minus pk. So if I look here, I should have sort of said that. I'm going to scroll up for 1 second to look at my summary for 1 second. Oh, stop, please. So notice that if the y is squared, okay, then notice that this I don't add anything. That then the thing that I'm adding to the a to or subtracting is for the x coordinate. Okay, so if this was y squared, then I'm not doing anything to the y, I'm doing it to the x. If it's an x squared, I don't do anything to the x, I do it to the y. Okay, so I do it to the y. So if there's a y squared here, I do everything to the x, but not to the y. If there's an x squared here, I do it to the y, not the x. Okay, and this will be the same sign as this, whereas for the directrix it'll be opposite. So for the focus, it's the same directrix as the opposite, and that always sort of holds through for all of these. Okay, so now let's get back to this problem. Okay, so here it is. Okay, so it's just since it's a y squared, I'm going to be doing the changes to the x. So it's an x h minus p. So the focus is at, I forgot what was it, 2 minus, is it positive 28? You should be adding. Okay, so it's 2, it goes in the same direction. So 2 plus, so it'll be a 2 plus 7, which is 9, minus 1, and the directrix will be y minus k. Oh, we're doing the x's because it's a y squared. So it'll be x minus h equals negative p. Okay, and so this says that the directrix is x minus h2 is 7. And so the directrix is x equals negative 5. So that's my directrix. Okay. Find an equation in standard form of each parabola. Okay, so let's do that. So the vertex is at the origin, and the focus is at 0, minus 3. So the thing that's changing is the y. And so it's got to look something like x minus h. Oh, the vertex is at the origin. So x squared equals 4py. So it has to look something like that. And so, well, let's see what it is. In this case, the distance from the way you go from the vertex to the focus is you subtract 3. So p in this case is negative 3. So therefore, I have that x squared is equal to negative 12y. And that's the equation of your parabola. So you're done. Let's do one more, I guess. The vertex is at 3, 5. Okay. And the directrix is x equals 6. And so the y must be the one that's fixed, so it has to be a y squared. So this is y minus k squared equals 4p x minus h. And let's figure out what each of these are. Well, the vertex is at 3, 5. So that's what h and k are. They're just the coordinates of the vertex. And the directrix is a distance of 1. Oh, I'm sorry. I said that completely wrong. The directrix is here 3, from x. And so 3 minus 6 is a negative 3. So I have to go I have to go negative 3 to get to my focus. And so P is equal to negative 3, or in the directrix, I have 3 minus 6 is a negative 3. And so I have, well, let's see, 1 minus k squared equals 4p, negative 12, x minus h. And that is the equation of my parabola. Okay. Oh, and that's it. Okay, so that's it.